So our project was Intangible gesture tests for autonomous vehicles, and I'm Dan, and this is Jhad.
So our goal for this project was basically to create a gesture-based interface using the Microsoft HoloLens to execute a specific task of our choice. The task we chose for the specific case is recording, highlighting, or bookmarking different lengths of an audiobook or of an audio file. So if you hear something that you want to record, you want to save, you can go ahead and do that with a gesture. And the way we wanted to test our application was by using a driving simulation.
So our original prototype was that we were taking a large block and we're going to put it on the screen in your view, and as you moved, it'll stay in your view, and when you click, it'll be anywhere you are, so it'll interact that way. And so we code this block to register click, and then eventually we end up adding voice commands, which we'll talk about soon. So before the user pressed anything, the screen was originally blue, and then once the user interacted with the interface, it would turn red, and then that was our initial implementation to adding the voice commands and all that stuff to happen for recording the audio device. And this is just a view from the user's perspective. So here's our preliminary data.
So we did realize as we were going through this that there was going to be some sort of delay from when the user hears something they want to record and when they actually realize, oh, it's time to record. And also there should be a delay from when the HoloLens registers the click. So we wanted a way to figure out how we could get this delay. So what I did was I sat Dan down and I played a bunch of songs that Dan did not know, and I knew where the chorus would start in those songs. So I had him listen, decide when the chorus was beginning, and go ahead and click the record button, quote unquote, on the Microsoft HoloLens. So from there, I was able to take out the actual starting time of the recording and the starting time that I wanted Dan to record and find a variation. And with that, we found that the average delay time was 3.6 seconds. So again, this gave us an idea of how many seconds before the original click that a recording should begin when we actually implement this into our project.
So the updates since then. So since then, we added a visual aid to show the user when the audio is playing and when the recording has begun and ended. So as opposed to our initial implementation of having a big blue or red block in your view, we realized that'd be very distracting, even if it was mostly clear, just because it would change the hue of everything around you. So what we did was we made the whole background clear, but the block is still there. It's all around you. You can press it anywhere you are. But we added a little green circle that you can see in the image there, that once you press the play button, the audio would begin. And so that's the green button is just, the green light is just to indicate that. And then on the right side of the word that says stopped in the image is a gray LED also that lights up red when you start recording, and then when you end recording, the text recording is stopped will show. And so that's one thing we did. Also, the display follows the point of view of the HoloLens, so as you turn, the gaze will turn with it. And we added visual statistics. So in this image, you can see that we added time elapsed, which is just how long the audio file has been playing for. The recording started, which is just when you start recording, it'll just mark that timestamp. The recording stopped, when you click again, it'll mark that timestamp, and just the difference to get the total length of the recording. We also implemented voice commands. To play the audio file, you would say play. To start recording, you would say record. And to stop the recording, you would say stop. And just overall, we made it a lot cleaner without a big bulky block in front of you. It's still there, but you can't see it anymore. And so that's what we did for those updates.
So we ran into a couple of issues while we were going along in our project. The first issue we had was with our voice commands. We noticed that while we were trying to test our voice commands, that the HoloLens is having difficulty deciding what audio was coming out of the audio file that was being played and what audio was coming out of the user's mouth. So a bunch of false positives were found, and we had to just completely throw away that data. We did not realize, and we didn't take into account for that when we were implementing the voice commands. Another issue we ran into was being able to play the audio files through the HoloLens itself. For some reason, we could not get the file playing, whether it was because it was too large or whatever the reason may be. We tried Tried a bunch of different things, including trying to put a video out of the user's view and play that with the audio playing with it, but that also didn't work. So the way we had to work around this was add the play button that Dan mentioned on our application and have the user click the play button as the audio file began so that it would start at the same time. Another issue we ran into was Unity. That was the software implementation that we started with. Really bulky, really clunky. It took too long to implement what we were trying to implement, so we set out to find another way to be able to code the HoloLens, and that's when we found Buildwagon, which is an online HoloLens development platform, and that worked out much better for us, saved us a lot of time, and we felt like we were just able to move along with our project much better. All right, so now we're gonna go ahead and talk about our experiment. So this is how we conducted our experiment. First, we found 12 people that were willing to participate, and from there we trained them with the basics of the HoloLens, made sure that the field of view was set up correctly, showed them how the HoloLens registers a click, what the gestures are like, and all that. Just a really small, like 3-minute intro. From there, we put them in front of a driving simulator. Unfortunately, in the lab, the driving simulator is not functioning right now, so we had to find a YouTube video, first-person YouTube video of a Tesla, and we asked them to focus on this as if they were actually driving. We were then told them to press the play button to sync with the audio recording. As you will hear in our demo, the audio starts with a 3, 2, 1 press play, and they have to press play as that goes along, so that way we could collect our data. And we told them to record every time they heard a date and time. So what that meant was go ahead and click with your hand every time you heard a date and time, and then click again when you were done hearing this important information. We watched their view on the HoloLens device portal on the computer and would take note of their start and stop record times that we have, so that way we could collect the data. And then they were asked to fill out a brief 6-question survey afterwards. So that may have sounded super confusing, so we have a video to show you exactly how that experiment would work.
Hello there. Thank you for participating in our experiment. Please prepare to click the play button. Audio file beginning in 3, 2, 1, play. Hey friend, just calling in to see how you're doing. I heard that you just got an addition on your house. That's awesome. I wanted to know if you could do a few favors for me. Do you mind stopping by my house and picking my son up at daycare tomorrow around 4 p.m. at the Durham Daycare Center? I just have a meeting at that time and won't be able to make the pickup time. By the way, I'm not sure if I mentioned this to you, but we have a meeting with the CEO of the company next Friday at 2 p.m. in the 342 office. I'm definitely excited to hear what he has to say.
So hopefully that gave you guys kind of like a better idea of how our experiment was run, how the gesture worked, and how what the audio file that we were listening to was like. So here's our true recording start and stop times. So as you heard in the recording that we just played, there were different instances where there were things that we wanted the user to record. Basically every time a date and time was mentioned. So there were 4 different pairs of date and times mentioned. The first one was from 27 to 33 seconds, the next one was from 50 to 57 seconds, the next one was from 79 to 84 seconds, and the last one was from 98 to 103 seconds. So what we were doing, we were looking at the top right of their view, taking those timestamps and comparing them to what we actually wanted them to record, seeing how accurate they were.
So here are the results that we have. So I'm just going to give you a brief overview of this because it's a lot of information to look at. So this is just a table of all of the participants and the data that we collected. So we have a recording for the start time and the end time of each individual recording, giving us 8 pieces of total columns of data. And so then we took an average of that, compared it to the actual, and saw what the difference was, just to see like how off or how close everything was, so we could find a % error and see how accurate our delay that we implemented into the system was in terms of accuracy. So just continuing that, the top table is just the average length recording. So with the data that we just showed you in the previous slide, you can see that for recording 1, it was 7.35 seconds was the average length of the recordings. from all the users. So we just wanted to see how much more or less they were recording than they were supposed to be. And what we found was that on average, all the users would record more because they had never heard the audio file before, so they didn't know what to expect. However, a few users, if we go back, you can see a couple of them jumped the gun with the recording on recording 2. So for instance, participants 5 and 6, you can see started their recordings at 49.3 and 47.9 seconds right over here. And when in actuality, it was supposed to start at 50. This may have been they heard it right when it happened, so then they clicked, and our 3.6 seconds threw them back a few seconds, because that's the time that we were looking at was after the delay was added. And then this percent error table at the bottom is just a percent error normalized over the full 107 second video. And so we actually had an average percent error of only about 1. So from what I see, the recording start to end from the first one to the last one, the users seem to get better at using our system the more they used it. That means that the user was getting used to using the device and getting better clicking and just liking it better, it seemed like.
Okay, so as I mentioned earlier, we gave the people that were doing our experiment a survey after they completed our experiment, and it was a 6-question survey. The first question said, did you find this application enjoyable to use? 92% of those people said yes. The second question asked them, did you feel that using our application was distracting while driving? Unfortunately, 25% of people said yes, which is a number that was higher than we would like. Our third question asked them, could you see yourself using this application practically? 75% of people said yes. Our fourth question asked them if they saw an advantage of using this application. 92% said yes. Question 5 said, would you prefer using this application over a tangible interface, which is basically a physical button? And every single person we surveyed said yes. Question 6 said, do you think you were able to record everything that was intended to be recorded? And 67% of people said yes. So we were able to draw a few notable conclusions from that information. The first thing we noticed was that more people were distracted than expected. That was 25% of people said yes, they felt like they were distracted. We think that more people were distracted because of our timestamps that we had every time they were recording. As you saw in the demo, we were showing the timestamps on the screen, and we did realize afterwards that yes, that would be pretty distracting while driving. However, that was the way that we were collecting our data. One thing that we kept in mind was that if we were actually doing this in real life and we weren't doing testing, we would not have those timestamps there, and we think that would bring our percentage of people that felt like they were distracted down significantly. Another thing we noticed was that all 12 people, so 100% of our participants, preferred this to a tangible interface. Now, this may be because they felt like it was more useful, but we also wanted to take into account the fact that everybody preferred this probably because of the quote-unquote cool factor. It's new technology, it's something they've never tried before, and when something new comes out, everybody would prefer using that to the old ways. And then the last thing that we noticed was that the average collected start value was about 1 second late when we were comparing that to the true start value. So basically what that meant was that average delay that we calculated with our preliminary data, that 3.6 seconds, if we had brought that back to 4.6 seconds, everybody would have fully recorded everything that they needed to have recorded. So now we know that our delay should be 1 second more than it actually is.
Lastly, I just want to thank all the participants who were able to make it. Though our first experiment didn't work well, so they had to come a second time. And so thank you to all you participants. And lastly, I want to thank Professor Kuhn for letting us work on this project throughout the semester. It was a really fun project, and we hope we could do more stuff like this in the future.